So again, just because we're getting a lot of questions about this, if you want to use a different IDE, you're more than welcome to. So please feel free to use a different IDE if you're comfortable with Jupyter Notebooks or you're comfortable with Google Colab and you want to practice in there, you're more than welcome to. We just are saying you can use Replit because it is easier. Again, we're sorry that you have to create and sign up for another account. This is just the case when we have such an interdisciplinary curriculum. It does, sometimes happen where it's not compatible across the board, but feel free to use any IDE that you prefer to code on. If you can't download anything, it's totally okay. What we're going to be learning largely today is syntax, so you can follow along and take notes, and that's also fine. And again, we'll go over the homework at the end of the lecture and how to access it via the Jupyter Notebooks or Google Colab. So that's fine. And with that said, I would love and I'm very excited to introduce your coding instructor for the next 2 weeks. AJ, he is a software engineer at JP Morgan Chase, and he will be teaching you the fundamentals of Python again this week and next week. We're really excited. You need to know Python and all of the concepts that we're going to be teaching this week and next week, so you can go into quantum computing. So yeah, we're very thankful to have AJ teaching you today, and I'll turn it over to AJ to get started.
Awesome. Well, thanks, Kiera. I'm so glad you're all here. I'm happy to be able to instruct you for the next couple weeks. We're going to be learning a lot of stuff in a very short amount of time. Some of you might know, some of it might be brand new, but we are going to move at a pretty fast pace. So if something doesn't make sense right away, don't feel ashamed. I'm throwing maybe like a whole university first few months of material at you in these next 2 weeks. So it's going to be great. I'm sure you all do great. I'm going to start sharing my screen. Kiera, can you confirm for me that that's showing to everyone?
We can see
awesome.
Your screen.
All right, so I just want to give a quick little intro about programming. I realize that some of you may already know how to do some Python, and that's totally fine. I will be teaching at a very basic level for those who have no experience. So if you do know some of the stuff that we're talking about, feel free to follow along. Feel free to maybe try some more complicated things on your own. But I will be going as if you have no prior Python knowledge. So if you don't have any knowledge, that's where we're going to start off from. And so another thing I like to clear up with students is when I was younger, I was like, oh, I got to learn Python, and then I got to learn Java, and then I got to learn C++. And the thing is, it's kind of like riding a bike. That's the analogy I like to use. So if I can ride one bike, then if my friend gives me another bike to ride, it might be a little different. Like if my bike is Python, I might be able to ride my friend's bike, which is Java. It'll just take me a little getting used to. But knowing how to ride a bike and knowing how to program are very universal. So once you learn some Python, you'll be able to translate that to Java very similarly. You don't have to go learn Java all over again. So mainly focus on the core concepts of programming, like our loops that we'll do, our functions, our variables. Once you know those concepts, then you can apply them to any language very easily. You don't need to worry about learning every new language that pops up around the world. Last thing I want to note before we start writing some code is that there's a lot of buzz around algorithms. You always hear, oh, these artificial intelligence algorithms, and it kind of sounds like, whoa, this is very complicated. But an algorithm is just a set of steps to complete a problem. So you might give someone an algorithm when you say, oh, like the room is down the hall on the left. That could be an algorithm. Or let's say me and my friend are both on watching Netflix. They might say, oh, well, let's recommend me a video based on what my friend watched. So let's see what he or she watched most recently, and then let's refer that to me as my recommended video. That's also an algorithm. So don't think that an algorithm has to be some crazy complicated thing that only really, really smart people can do. They're very basic at their core. And now we're going to start getting into some code. So as Kira said, we will use Replit. I will use Replit to show you my examples. And if you have previous experience, you want to use your Jupyter Notebook, you want to use your Visual Studio Code, that is up to you. And you can follow along with that. But if you are new, I suggest using Replit, and you'll be able to follow along with me on all of our examples. So I'm going to take you there right now to give you a little overview of what Replit looks like. So I hope that everyone who's going to use Replit has signed into their account. So once you're signed into your account, you will see this kind of home landing page. And the way that we get to actually coding is this new REPL in the top left corner. So hopefully you'll see new REPL, and we can click that. It'll now ask for our language, which we will choose Python. And this is just a random word structure that they make it unique. You don't need to worry about this little thing here. And we will click, once Python's in that box, we will click Create REPL. So I hope everyone is following along, because this is really important for the rest of the lesson. New REPL, Python, and then Create REPL here. So this is the screen that we'll be dealing with to write our code. You see this main.py in the middle of the screen. This is where we type. Our code will go in here. And then we can click this run button to run whatever code we've written in this main area. And on this right side, it will show us the output of our code. So type here, click run, output over here. There's no need to worry about this file system right now. That's a little beyond what we're covering. So mainly just worry about typing in here. I saw someone ask, what does IDE stand for, or what does that mean? That just means Integrated Development Environment. Don't worry about the big words. All it means is a place to run your code. That's what an IDE is.
AJ, is it possible for you to zoom in at all when you're on the IDE or when you're on Replit?
Yeah, let me see if I can.
Awesome. If you could just zoom in a bit, that would be great.
Maybe one more. How's that look? Will it cut off anything on this side? No, I think that should be good.
Yeah, that's great. Thanks.
All right, awesome. So I am going to come back to my slides real quick. All right, so let's start writing some code. Print statements is the first thing we're going to learn. And a print statement is just a way to print something out once your program runs. So when my program runs, I might want to print, hi, my name is AJ. Maybe today is November 22nd. So the way that we do that in code is we type the word print and then an open parenthesis. And then inside quotation marks, we write whatever we want to print out to the user, whether that be your name, maybe that's today's date. So let's go do it in Replit and see it in real time. So you can follow along, or you can watch me for 30 seconds when I do my example, and then I'm going to give you a exercise to do on your own. So maybe just watch this, and then you'll have time to do it on your own Replit. So I might print, I type the word print, and as soon as I do this open parenthesis, in quotation marks, I can say AJ. Maybe below that, I can do another printout to this area that says, today is November 22nd. And once my code is typed, I click this run button, and over here you will see a printed out version of what this code returns. So hopefully simple enough. Now my exercise for you is to do some print statements of your own. I would like you to, how about print your name and then print your favorite movie or film. So go ahead and take a minute to do that now. I'll give you a little bit of time to try it on your own. All right, so if you are still typing, that's fine. For the sake of time, we're going to keep moving, but I hope you got a good grasp of how to print something out with your program. I'm putting the text inside these quotations and then wrapped inside this print. Cool, so I am going to return to the next topic in the slides, and that is comments. So we know how to print something out. We know how to execute a line of code. We just wrote our first code. But what if I want to type something in my code that I don't want the computer to run? So maybe I have a lot of code and it's kind of confusing for someone to look at, and I want to maybe write a little bit of an explanation above the code that says, hey, if you're looking at this code, this is a program that prints out all of my favorite movies. And the way we can do that is with what we call a comment. So if you type a pound sign, maybe hashtag, whatever you want to call this sign here, then whatever is after that pound sign does not get run by the Python program. And let me show you that in Replit. So we had our normal code here. I've got two print statements. And watch what happens if I type a pound sign at the start of line 1. First off, the code kind of goes a little gray. And then when I press run, it no longer prints this first part. It only prints the one that doesn't have a pound sign at the start. So notice how the computer ignores it completely. Also, what I want to show you is that if you don't put the pound sign at the start of the line, if you put it maybe after the code you want to run, the code will still run itself, but whatever's after the pound sign won't run. So maybe after this line on line 2, or I'll uncopy or undo that one. And maybe after this, I just want to put a pound sign here and say, hi. Notice that this line runs again, but anything after the pound sign does not get run. So if I were to add another print over here, that would not get run. So after pound sign does not get run. So with that example, let me give all of you time to experiment with that on your own. What I'd like you to do is maybe comment out one full line that you've written. So put one pound sign at the start of one of your lines and make sure that that no longer prints. And then practice a comment on the same line as some real code. So try both of these tactics. I'll give you about a minute to try that. All right, so once again, for the sake of time, we're gonna keep moving. If you didn't finish, that's all right. And if you're just following along and you might not have an IDE up, feel free to just jot down this syntax, and it's pretty flexible on how you wanna document this stuff. So let's go on to the next topic. We'll do some practice at the end to make sure you can get more exercises with comments and stuff. But our first main topic, so printing's nice, but let's get into some actual very important topics, variables. So a variable is something that gets assigned a value. So I might say, I have 3 cats. So I want to create a variable. I'm going to call it cats, and it's going to store the number of cats I have, which is 3. So these 3 cats, and then in code I would write cats equal sign 3, just like you see on the bottom of the slide here. So now going forward, anytime I refer to cats, anytime you see cats in my program, that will actually refer to the number 3, because that's what a variable does. It stores some data for later use. And there are different types of variables that we'll be working with. You've got the integer type is the first one. If you've never heard the word integer before, a whole number, positive or negative whole number, no decimal, is an integer. We've got floats. Some examples might be any decimal numbers, positive or negative. So if it has a decimal, it's a float type, not an integer type. And then string type is what we've worked with printing. We've printed strings. So if you have anything with quotation marks around it, single or double quotation marks, that is going to be referred to as a string. So apple with quotation marks around it, that's a string equal to apple. And last is list. List allows us to hold multiple things in one variable. We're going to look at that later. Don't worry about lists. The main things we want to focus on right now are numbers and strings. So numbers being integers or floats, and strings being these with quotation marks. So let's go back to REPL and let's make some variables. So I'm going to take out our print statements. So if I want to make a variable, I'm going to call my first one x. I can say x equal to 5. That is an integer variable named x. So now watch what happens if I go to print x. It will actually print 5 because I said, okay, anytime I refer to x, actually look at 5. And then this print x will print out that 5. If I change this to 6, it'll print 6. Let's try it with maybe a float. So y equals 3.14. And if I print out y, printed the 6 from line 2, and then printed 3.14. And lastly, let's do a string. So I might call a variable pizza. Pizza equals buffalo chicken. And when I print out pizza, it will print out buffalo chicken. So I hope you, at least this makes some sense, and I'm going to give you some chances to do some variables on your own. So first one I'd like you to do, make a variable called age equal to your age. Second one, make a variable called height equal to your height in whatever measurement system you want to measure height with. So hopefully your age will be an integer, it'll be a whole number, and your height might not be a whole number. I might not be 2 meters tall, or I might not be 5 feet tall. So that might be a decimal number, and it'll be a float type. And last, I want you to make a variable that is equal to your favorite food. And then at the end, print them all out. So these are your 3 instructions. Go take a minute to, or well, I guess 4. I want you to print them out too. So go ahead and try these 4 instructions on your own. Use this as reference if you need to. And I'll check back in a minute. Gonna give you a little bit more time to finish up.
AJ, we had just a few questions around when to use spaces and when to use quotation marks. So like with the previous prints that we were using quotation marks, those are not needed when you're using numbers, is that right?
Ah, yes, I see what you're saying. Yeah, so in regards to the quotation marks, if the item is stored in a variable, then you do not need quotation marks. But if I was just printing buffalo chicken on its own, then that would need quotation marks around it, because this pizza is the equivalent of having it refers to this buffalo chicken with quotation marks around it. So yeah, if you're doing a variable, you do not need to put this pizza in quotation marks. Otherwise, it would actually just print the word pizza rather than the buffalo chicken that this variable is supposed to refer to.
Perfect. And then someone asked, why wouldn't it just be easier rather than creating a variable just to print the number in these cases? So can you provide an example of like when we might be using something more complex where variables would be helpful?
Yeah, absolutely. So that I think that totally makes sense to ask that question. Why would I print out the variable the pizza variable instead of just printing out buffalo chicken? And for this example, it doesn't make a ton of sense, but once we get into these more complicated things, especially when we get into functions, you will realize it makes a lot of sense to use the variable because it saves you a lot of time from having to rewrite a ton of code. So without a function, I think I'm just going to say hold off on that. It'll make sense eventually, but that's a great question. I can see why people, why someone would be like, well, how is this useful? We'll get there. All right, so I think that's enough time. I'm going to quickly maybe go over some examples of what it might look like. So your age variable, age, $, and then your integer number, maybe height. You can do float number, and then maybe a food variable equal to pizza, and then you would print them all out. So I hope that's the solution. To some extent, you would have different values here, but this is what it should look like. So I'm going to give you a few seconds if people are kind of checking that or copying it down. And we're gonna keep moving on. All right, so back to the slides. Don't get freaked out. There's a lot of text on these slides, and I usually don't like to put a lot of text on slides because whenever I was learning, I never liked to see a lot of text on the slides. But the main takeaway is when I'm naming a variable, how do I want to do that? Am I able to just call it whatever? Am I able to maybe use an exclamation point in my variable? Maybe a money sign. I want to put some money signs in my variable. And unfortunately, there are some rules. So the standard we like to follow is use lowercase letters. And if you want to have a variable that's multiple words, such as grocery list, then separate it with an underscore. So stick to this format on the bottom of the screen as much as you can. And you can't start a variable with a number. Your variable can't have spaces or any fancy characters in it. So just note that there are some restrictions when naming a variable. Stick to lowercase letters and underscores as much as you can. That's kind of some, for the most part, good consensus across programming. All right, so now we're gonna look at how we print a variable along with some of our own writing. So we've printed our own writing, we've printed variables. What if we wanna do both at the same time? And the way that we can do that is after we create this food variable that is equal to pizza, whenever we print, we can do our normal print with I like to eat or whatever text we wanna say. And then we can do a plus sign with the variable name after it. So let's go to Replit to see that in action. All right, so what's a good one here? Dessert. We're gonna make a variable called dessert. And it's gonna be equal to cheesecake. So I want to print out, and once again, sorry, this is me. This is something you can just follow along, and then I'll give you your own exercise after this. So feel free to just watch this. I'm going to say my favorite dessert is, and then obviously I could type in cheesecake here, or I could print, close the quotation marks, and then do a plus sign and say dessert. So after I put my text, plus dessert, my favorite dessert is cheesecake. So I think a good way to understand why this is useful is, let's say I had 50 print statements here for whatever reason. So I have 50 lines and they all say my favorite dessert is cheesecake. So the reason we use a variable is, let's say I want to change what my favorite dessert is. If I don't have this variable in use, then I would have to change all 50 of those lines to not say cheesecake, to change it to whatever other string we're talking about. But here, if I'm using the variable, all I have to do is change it in one place. And if this variable is used in all 50 of those lines, then it will update all of them. So that's kind of why we do it. So we save time if we do want to change the code later. So, all right, this is the template to go off of, and your exercise is going to be make a variable that's your favorite dessert. Let's just stick to the same one. And after that, print it out. print that your favorite dessert is blank, followed by whatever dessert you choose. So go ahead and take a minute and try that out. All right, for the sake of time, we're gonna keep moving. If you're struggling with these, don't worry at all. We'll keep practicing them and it'll definitely make sense. If you're whizzing through it, good job. So back to slides, we're gonna talk a little bit about math. And this is gonna be our last section before a little break. So stay with me if you're sort of not as engaged. I assume if you're in a quantum computing course, you probably like math. So we're going to give you a way to do some math in Python. And the four main operators, we're going to focus on just the basic ones for now. So addition, subtraction, plus sign, minus sign. Multiplication is the little star on your keyboard. For mine, it's a Shift 8. If you're on a standard keyboard, it might be different, but it's that little star. And division is the slash. So anytime you want to multiply something, you would do one number multiplied by here, 3 times 2 equals 6. Division would be 10 slash 2 equals 5. So let's do it in Replit. Let's go back to our IDEs. So I want to print out maybe 5 plus 2. And once again, you can follow, you can just watch this and then I'll give you your own examples. Maybe I want to print, let me run that so you can see. What's 5 plus 2? 7. Should print out all good. Print out maybe 5 minus 2. Run that. You'll see 7 and then you'll see 3. Maybe I want to set x equal to 10 divided by 2. And if you run that again, you'll see, oh wait, just 7 and 3 are there. That's because we haven't done anything to print out x. We just stored it in this variable. So only these two are causing any output when we run our program. And then if I print x, it'll now take the result that it got from here and print it out. So 5. And let's also print, maybe let's say a different variable y equals 10 times 10, and we'll print out y. So the code obviously runs from line 1 down, so that's why the 7 is printed before the 3, if ever anyone was confused on that ordering, and then the 5, and then the 100. So that's how we do some math. That's how we print some variables with math. Your assignment I want you to do real quick to practice. Print one example of addition. So with the plus sign. Do one with subtraction. One with multiplication and then one with division. So go ahead and try these now. And try to use the variable at least once in these exercises. Maybe instead of just printing out 5 plus 2, maybe try to store it in the variable first and then print the variable. If you're looking for a challenge, maybe try to do one equation that uses all 4 symbols at the same time.
AJ, some of our very detail-oriented students are noting that the 10 divided by 2 is coming out as 5.0. Is there a reason that it causes float numbers rather than a whole number?
Yeah, so that's a great point. It did, before I messed it up with this other, with the instructions, it did say 5.0 over there. So that's just a Python division will, I think, always default to a float value. It won't do so for addition or subtraction, I think, or multiplication, but when you're dividing, since you're more likely to, when you're dividing, get a decimal number, it will default to a float value. So yeah, don't look too far into it, but that is a good point. When using division, it will usually come out with the decimal.
AJ, I think another good question is when you have a variable like x and it equals 10 divided by 2, why doesn't it print out 10 divided by 2? Why does it print out 5?
Yeah, absolutely. So the way that Python sort of interprets the slash that we use for division, it treats it like an operator. So anytime you put a number and then slash another number, if I said x equals in quotation marks and I made a string like that, then it would print 10 divided by 2. But if you don't put the quotation marks, it will assume that this is a mathematical, once it sees the slash, it'll say this is a mathematical equation that I'm supposed to create a result for. But yeah, if anything is in quotation marks, it just interprets it as whatever the text is. It won't do any of its mathematical stuff. All right, so I hope that was enough for people to get an attempt at arithmetic. Kira, I think this is where I have the break situated. Do you want me to move to the next topic, or should we take a 10-minute break now?
I think you could go to the next topic and then let's stop at 3
Okay.
time, so 15 minutes.
All right, awesome. I'm going to clear this. All right. So almost at a break, but let's talk about a new type of variable. So we've dealt with these number variables. We've dealt with the strings. List, I said, we'll worry about later. And there's also this type called Booleans. So this is something that if you're not familiar with programming, you've probably never heard before. And Boolean refers to one of two things. There's only two possible values. While an integer variable could be 1, 2, 3, 4, 5, like a ton of different options, a Boolean type can only be true or false. True or false. Capital T, when we're in Python, capital F, the only two options. And the reason that this is useful is because a lot of logic is used in programming. A lot of logic is used in computers in general. If some of you may have been dealing with the logic gates that is part of this curriculum, not sure if you've seen that yet, but this true or false helps us say logically, can we do something? Is something true? Is something false? So let's take a deeper look to see some examples of this. So when we're trying to figure out, is something true or false? Like what's dictating that? Like, how do we decide that? And one of the ways we can do it is with these comparison operators. So I'm sure most, if not all of you, have seen greater than sign before. So if one number is greater than another, 5 greater than 4, 6 greater than 5, less than sign, equal to, down here, these two equal signs, meaning are the numbers equal? And then not equal to, this exclamation point followed by an equal sign. That might be a little odd syntax for people who have never done this before, but that means not equal to. So let's look at a couple of these examples down below. Remember, we're always trying to equate to true or false with these Booleans and these comparison operators. So 5 greater than sign 2. That is true. Why is that true? Because the number on the left, 5, is greater than 2. So that we mark that as true. 2 equals 7. That's false because 2 does not equal 7. And that's saying, is 2 equal to 7? No, it's false. So if I were to set a variable equal to 2 equals 7, that equation would be false and the variable would equal false. One more example. 1 not equal to 3. What do you think that is? It's true, because 1 does not equal 3. If it said 3 not equal to 3, that would be false because 3 does equal 3. But 1 not equal to 3, that's a true statement. So it kind of gets tricky in your mind. This stuff is not as easy as maybe print statements or variables or arithmetic. So it might take you a little time to get used to. Let's go try a little bit of it in Replit. All right. First one we want to do, I want to print 10 greater than 5. And as always, this is me. I'll give you some time to do, you can follow along or you can type if you want, but I'll give you some time to do your own shortly after. So what do we think this would print? It's true, because 10 is greater than 5. Print 10 greater than or equal to 5. That one's true as well. What about 5 greater than or equal to 5? That one's true too, because 5 is greater than or equal to. Let's try a different symbol. Let's say print 1 not equal to 1. That's false, because this is saying 1 is not equal to 1. That's false. 1 is equal to 1. So once again, tricky to get used to, but think of it as this statement, evaluate it. Is that true or false? Is 1 not equal to 1? No, that's not a truth. 1 not equal to, no, doesn't make sense. Let's get some variables involved and then I'll let you try some on your own. So I'm going to say x equals 50 greater than, I'll say 50 less than 100. What do we think? Is that true or false? Well, I'm going to run it, and then I'm going to print out the variable x to see what it stored here. So it evaluates this, stores either true or false in x, and once we print x, it's saying that's true. 50 is less than 100. So now what I would like you to try is, I want you to first print out a true scenario using the greater than operator. Next, print out a true scenario using the equals equals operator. So equals equals is true whenever the number on the left equals the number on the right. And lastly, print a false scenario using the less than operator. So a false scenario would be where the number on the left is not greater or is not less than the number on the right. Go ahead and try those. I'll give you a few minutes. Sorry, I deleted the instructions. I don't think I can undo it. I'll retype them out. I'm gonna add a little challenge exercise at the bottom if you're looking for something All right, so we are going to move on to our next topic. No problem if you were still doing that. We'll come back to more practice. And I think with the material we're learning now, it is kind of like, well, what did we just do there? Like, why is it useful to know if something is true or false? And that's another thing that we will find out. We will discover why we want to know if something's true or false. And you kind of just got to stick with it, and those questions will be answered. But I totally understand if right now it's like, oh, well, like, that's cool, but what could I actually do with this? So now we want to talk about Boolean logic. And this is going to be another one of those little mind riddles that we want to think about. So it still involves true, true and false, different conditions. And it's three main operators: an and operator, an or operator, and a not operator. So I want to focus on an example in order to explain this. So let's think about myself. So I have a puppy and I do not have a kitten. So those are two things about me. So I have a puppy, that would be true. If I had some variable that I wanted to store me having a puppy, that's true. If I wanted to store some variable about me having a kitten, that's false, because I don't have a kitten. So puppy, true; kitten, false. And the way that we can sort of use multiple conditions and evaluate like puppy and kitten. So let's look at this little Venn diagram here on the left. I hope that you all understand what a Venn diagram is. If you don't, that's totally fine. You'll be able to get this with practice. But the Venn diagram here says puppy and kitten is only true if I have a puppy and a kitten. I need to have both of those. So whenever you see the word and in Python, both things that are being considered must be true. So for me, if you see on the bottom here, puppy and kitten, that's not true because I don't have both a puppy and a kitten. I only have a puppy. So when you see and, both must be true. And because for me, I only have one of the two, that's not true for me. Let's move on to or next. So or does not require you to have both things on both sides of the or. So if you see puppy or kitten, it doesn't require you to have both of those. It just requires you to have one. So if I have a puppy, then that is true for puppy or kitten. If I have a kitten, that would also be true because you just need one of the two. Stick with me because I know this can be a little bit tricky, but it'll definitely make sense once we get into the replet. The last one I want to talk about is not, and that is just not kitten. So if I'm evaluating not kitten, that would be true for me. So in order for not to be true, you just have to not have whatever condition or item is being evaluated. So for me, since I don't have a kitten, not kitten is true. So let's do it on Replit because this is a really kind of tricky concept to master, and hopefully once we see it in code, it'll make more sense. So sticking with the theme of true and false, let's say, I don't want to use the same example. How about I say no Python equals true. So I'm creating a variable called no Python, and I'm setting it equal to true. What about no Java equals false? Let's say I don't know Java, but I do know Python. So these two conditions explain me, knowing Python, not knowing Java. So what I can do here is I can print out no Python and no Java. So based on what we know about and, both of these have to be true in order for this to return true. So I must know Python and I must know Java in order for this print statement to print out true. The problem is I don't know Java here. It's false. So when I print this out, this is going to be false because I didn't know both of those. Must know all of the conditions must be true. This one and this one. What about or? No Python or no Java. Or doesn't require both to be true. It just requires, do you know one of them? It's kind of like English. Like, do you know this or this? Do you know one of them? Yes. So because one of these is true, I do know Python. No Python or no Java will come out to be true. Just requires one of them. If no Python ended up being false, but no Java was true, this would also return true. And last but not least, let's talk about not. So not, no Java. When I run that, that's a true statement because it's saying the opposite of knowing Java. Do you not know Java? And that's true for me because I have false here for no Java. So the exercise I want you to do is I want you to create no Python and no Java variables for yourselves. You can consider yourself knowing Python because I'm teaching it to you now. So you can set no Python equal to true, and I want you to experiment with these same scenarios. So do and or not combinations for the two variables. So maybe you want to try print not no Python and see what that comes out to. Maybe you want to try printing no Python and no Python and explore what that comes out to. So remember, and all of them must be true, or just one of them has to be true. So go ahead and try these exercises. I'll give you a few minutes to give that a shot. And if you're completely lost, do not be discouraged. This is this concept takes time to understand, and it'll click. If not the first time, then definitely the second or third. All right, I hope that's going well. We will revisit. One note I do want to make is that you might be going, what's it matter if I know Python or know Java, or what's it matter if I, what was our other example, have a puppy or a kitten? So when I'm making a program, I might want to say, well, my program decides how much food should be given to an animal. And the reason you want to know, oh, do you have a puppy, or do you have maybe a full-grown dog, or do I have a bear, I don't know, or a horse, whatever pet you have. So you might want to give different amounts of food for different dogs. So you want to say, is this a puppy? Okay, well then maybe give this amount of food. And that's what we'll see when we get into if statements. It'll be a big breakthrough in your mind, like, oh, that makes so much sense now. But like, if something's a puppy, if puppy is true, then give this amount of food. If it's a full-grown dog, give a little bit more. If it's a horse, maybe give a bunch. So that's kind of how this could relate to a real life scenario, a useful program that you're writing. And I think we're going to head into break soon. So I don't know if Kira, you can keep working on this if you want to, but we're probably going to head to a break shortly.
We'll take a 10-minute break now. We'll be back in 10 minutes. If you, AJ, just want to put up the break slide so everyone knows. And don't worry, everyone, we'll continue to go through more of these problems and how print statements and variables and all the different topics that you've learned today relate. So there will be a lot more practice as well in the second half if you have questions. But as Akshay has said, and Yolanda has also said in the Q&A, feel free to try out some of these questions that you have. You won't break anything. And a part of kind of being a programmer is trying things out and seeing if they work or if they don't. And if they don't work, why they don't work. So we'll see you all in 10 minutes.
All right, so I hope most, if not everyone, is back from break. And before we get started with our last bit of material, we have some questions. So I've been able to get some of the questions that people are asking in the chat, and I'm going to try to answer some of them now. So first, you might be wondering like, oh, so why Python? Why did we choose to use Python as course? Is it because that's the only option for quantum computing? And Akshay is actually going to give us an answer on that one.
Yeah, so it's a really good question, and I think the reason is that so in the next semester we'll be using a Python library called Qiskit to implement all of our qubits and quantum gates and all of those operations. And Qiskit is implemented in Python, and Qiskit also allows us to directly interface with IBM's quantum computers and run these algorithms on the quantum computers. And that's why we are learning Python right now, so we can use Qiskit. Another very common implementation is called Circ, which is again implemented using Python, but there's no like fundamental reason why we have to only use Python. In the chat I've posted a C++ library for quantum computing, and that's just something that I have found by Googling. I'm sure that libraries also exist in other languages. It just happens that the two most popular ones, Qiskit and Circ, are implemented in Python.
Awesome. So yeah, you guys are learning Python, which has got some great libraries. That's news to me. I'm not the quantum specialist, so you'll have to go to Akshay with questions about that. So a few more questions. I'm going to go to Replit so I can answer these. It seems like people are asking a lot of kind of small syntax questions. So for one, do I need spaces between the symbols or between the numbers? Do I need to put a space in between the 5 and the plus sign? The answer is no, but it's cleaner and nicer looking if you do. So just kind of stick to that practice. What else we got? Someone asked about a multi-line comment. So remember, a comment is a line that has some text that does not get run by the computer. And we can do that. Normally we had everything after a pound sign was ignored. If you do 3 single brackets, not 4, 3, and then 3 more somewhere, 3 more of these down below, then anything in here, anything inside of this is a multi-line comment. Maybe we can comment. Another line, and here's another line. So if you want more than just one line, you can use this new syntax, or you can just stick to using the pound signs at the start of a line for it to be ignored. So great question there. Is order of operations built into Python? That's a great question. So obviously we know multiplication is supposed to be evaluated in the order of operations before addition and subtraction. So the answer is yes, that is built in, and you won't have to worry about like, oh, well, am I doing this correctly? Is it taking into account these operations? Is there a resource to find some of these shortcuts? So if you want to know like, oh, I don't remember what not equals is. So like, was it a @ sign equals, or no, it was an exclamation point equals? For that resources, hopefully these slides were sent out to you. You can always refer to the slides, or a quick little Google search for Python comparison operators should give you the information you're looking for in regard to that. And saving your work in Replit, I still haven't really done that before, so we can address that after class if you'd like. And the final question is in regard to and or. So remember, we did the ands and the ors with like have Python, or sorry, no Python, no Java. So we only had 2 conditions. And someone said, well, what if there's no Python, no Java, no C++? What if we've got like three items in a Venn diagram? Is that allowed? And the answer is absolutely. So I did most of the examples with only 2 for simplicity, but there could most definitely be 10 different conditions. And when you have the and, all of those conditions must be true for the whole thing to be true. And when you have the or, once again, you just need one of them to be true, whether it's one of the 2 to be true, or if there's 10, you just need one of the 10 to be true. So that's a great question as well. Let's keep it going though. We've got just a few more topics today, and the next one is lists. So I introduced this. You might have seen it on the variable chart, and a list is if we want multiple things stored together. So if you're familiar with maybe any other languages like arrays, a list in Python is very similar to array, and we'll whenever we use external libraries in the future, when you're doing your quantum stuff, if you use NumPy, we'll have arrays in that too. And it's just a collection of objects. Think of it almost as like a backpack that you're like, okay, I got bananas in there, strawberries, peaches. It's a structure that holds more than one thing. So these 2 examples on the screen, my list, we've got a list that has strings in it. So maybe some different foods in strings. Or we could have a list that has just numbers in it. So 5, 10, 15, 20. You could technically have numbers and strings. So I could have a list that has 10 and bananas in it. It is more likely to cause errors. So most of the time they always have the same variable type in a given list, but feel free to experiment with that on your own, what kind of works and what doesn't. All right, so extracting items from a list. This is going to be a little different than you might normally think. So we've got this list here, Z. Z is our list, and it has 4 numbers in it. So if I want to get the first number in this list, I want to take this 3 and get that value. The way that I can do that is I can type Z and then the square brackets, not the parenthesis brackets, the square bracket, and then some number inside these squares after Z. And the biggest difference is that when humans count, they count, okay, 1, 2, 3. But when a computer is counting, it starts at 0. So that's the biggest takeaway from these lists that you'll want to know, is that the first item in the list, we would say, oh, that's item number 1. But a computer starts counting at 0. So that's item 0 to a computer. Humans start at 1, computer 0. So if I want to get this first item, I have to say Z, and then in square brackets, give me the 0th number. Or the first, technically, the first item in the list. So that will print 3. And then if I say print 0 at the 1 index, that's actually 7. So it goes 0, 1 instead of 1, 2. And here you'll see the index of each one. So if I want to, I would say Z square brackets 0 to get this 3. I'd say Z square brackets 2 to get this 4, which is the 3rd number in the list. So it's all just shifted 1 because the computers count from 0. We'll get into that in Replit, and you'll hopefully be able to see it a lot better. The other thing we might want to do is add to a list. So our list does not have to be just the same thing all the time. If I have a variable called days that holds a list of days of the week, I might want to add Thursday and Friday. And the way we do that is we say the name of the list, which is days, period, append, and then in parentheses after append, we can enter whatever item we want to now make part of the list. So this would add Thursday to our list, and we would have another item added, and this would add Friday. So now we would have 5 items after this code is run. in the same way, you want to remove from a list. Let's say you have all 5 of these days now, and I want to remove them. We can do the name of the list dot remove, and then in these parentheses, we put the item we want to take out of the list. And after this code is run, it'll be back to just Monday, Tuesday, Wednesday in the list. So append to add, append, remove to take away. So let's see that in action on Replit or whatever other IDE you might be running your code on. So I'm going to create a list. I'm going to call it my list equal. And then to create a list, we use these square brackets, and I can put numbers or strings separated by commas. So 10 is my first one, 20 is my second one, 30 is the third one. So notice that in Python, I can print my entire list. If I say, hey, Python, just show me my list, it will print out the whole thing to your window over here. And let's say I want to add something to it. I want to do my list and then a period, append. And inside here, I'll do dot append. Inside here, I put whatever I'm trying to add to this list. So for me, let's add 25. And then I'll print my list again after I just appended 25. And notice that it's now added to the end. It always goes on to the end of the list. So now I have 25 here. Let's say I want to remove that 25 that I just added. I say the name of my list dot remove. And if you're struggling, if I'm going too fast here, I'm going to give you time to do it as always, so don't worry. My list dot remove with 25, saying dot remove, take this 25 away. And if I go ahead and print my list one more time, notice how we had these 3, we added the 25, and then we took it away, we returned to this last print doesn't have the 25 anymore. All right, so quick exercise. Make a list of 5 numbers. That's your first task. And then what I want you to do is remove all the even numbers. And then print your new list. So that depending on how many even numbers you have, try to put at least 1 in there so you can practice it. Don't try to, I know you probably think it's, oh, I can just do all odd numbers and I won't have to remove anything. So try to make 1 even number, practice removing it, and then print the new list out. I'll give you a little bit more time to finish up. All right, so totally fine if you're not finished, but we are going to move on. And I definitely want to make sure towards the end we show you guys how to keep your files in Replit. I'm sorry that I don't fully know how we save these, and I don't want to spend a bunch of time trying to figure that out now. So good job on that. I will, I guess what I can do is just kind of multi-line comment this. So if anyone's still kind of looking at it, I'll leave it down here. And now we figured out the adding and removing from lists, but remember those square brackets and me saying something about a computer counts from 0 may not have made any sense. Well, let's take a deeper look at that. So I'll keep my list. I'll use my same list of 10, 20, 30. And so what if I want to grab the first number in my list and I want to say print out the first number? So the way that I would want to do that is I would say, okay, or I'll just set it equal to a variable. I've got a variable x equals my list at 1. So I put a square bracket and then the number that I want to, the number in the list that I want to take out based on order. And what you'll see is when I go to print x, you'll be like, wait a minute, why is that not 10? I just said, hey, list, give me the first number in the list, but it gave me the second number. And that's what I mean by computers counting from 0. If I want the first number in the list, I have to actually say, give me the 0 number, and that will print 10 here. But otherwise, if I do the first number, a 1 here, it'll actually get me the second. And if I do a 2 here, it'll actually get me the third number in the list, and that will print 30. So my assignment for you is maybe if you have that same list from your code below that you just removed your even numbers, maybe add 3 more numbers to your list. And then I want you to print the third number in the list. So that would be my list at 2, not my list at 3, because the third number would actually be the second in a computer's mind. Let's go ahead and try that again. Give you a minute to do it. All right, so while everyone was finishing that up, I sort of did an example solution of what you could have done. Remember, all this does not get run. Anything that's in this multi-line comment, or if I didn't use this multi-line comment and I instead just made these start with a pound sign, that would also make the computer ignore them. And so I could append 3 things. You could add a massive number if you want to. There's no rules against that, really. So then I print my list at 2. Notice that's still 30. So that would be the third number in the third position. And then I just printed my whole list, so you can see that there's actually a bunch of numbers in there. So we got a question involving, could I put a variable in my list? And the answer is yes. There's nothing against you creating maybe like food equals apple, and then all of a sudden just being like, oh, put apple in my list here. There's nothing against that. Oh, sorry, I would put food here. So yeah, it's a little dangerous, because then if you update the variable, I'm actually not sure how that would impact the value in the list. So just be careful for now. That's all I'll say with putting variables inside your list. And cool. So we did a lot. I want you guys to be sure that, like, maybe you know a ton about programming and this was all a breeze for you. And if that's the case, we will go into much more complicated stuff next week. But if this is completely new, I just gave you probably 3 weeks worth of a university programming course in the span of the last hour and a half. So if it all seems kind of like, oh, I don't know if this makes full sense, no worries at all. You'll get there. Stick with it. We got print statements. We did variables and all of their different types. We did some math in Python. We did the Boolean logic by saying, is something true? Is something not true? And we did some list stuff. So I've got some practice exercises that is all you to go through. I think there's 3 here. Hopefully they're a little bit more fun. So the first one, create 2 integer variables, and then add those 2 variables together and store the result in a third variable, and then make a fourth variable that's equal to the third variable divided by 5. So this is kind of bringing it all together in a little more challenging way. So give it your best shot. And if you need some references, I'll try to add some example code up in this corner or something. So give this a try right now. All right, for the sake of time, we are going to go over it. So I'll go over the solution. Get rid of this for now. So first thing was to create two integer variables. My integer is going to be my variable name. I'll set it equal to 7. My other integer, you don't have to name them. You could have just named it X and Y, but I'll set that equal to 4. And then I think it said add them together, store it in a third variable. So I will say sum variable is equal to my integer plus my other integer. So this is saying make a new variable that is the sum of the other two. So since this is 7 and 4, this would be 11 now. Take that third variable, divide it by 5, and store it in a fourth variable. So the last step, we would say last variable would be a new variable, and it is equal to sum variable divided by 5. And then we print last variable. So we run this, we get 2.2. So 7 plus 4, 11. 11 divided by 5 is 2.2. So hopefully that's a glimpse into how you can kind of work with multiple variables, do a little bit more computation. The next practice exercise deals with lists, and like I said, it's building up. These are a little more challenging than the simple ones we did right after learning it, but I want you to create this list in your program, Z, and then print a number that is 5 less than Z at 1. So you'll want to use this Z at 1 to get that value, which in this case is 75, and then print out that number minus 5. Here you want to print a number that's 300 times greater than Z at 4. So you want to grab this Z at 4 value, which refers to not the 4th, but the 5th number in this list, so 90. And you want to multiply it by 300. So it's a number that's 300 times greater. And then print the number that's half of Z of 0. So half of whatever you get when you use Z of 0. So I'll add a little reference if you're still confused, but go ahead and try that now on your own. going to give a little bit more time for this one. Also, I should note that these list references are just like example code of how to use lists. So it doesn't mean that this is part of your solution at all. So if you were confused about that, don't worry. All right, let's go over it in Replit. So we want this list Z that I shall make here. And we've got 15, 75, 25, 45, 90. We've got this list we're working with, and then the first one says print a number that's 5 less than Z1. So I can print Z at 1 minus 5. And that's 70, so it's Z at 1 minus 5. Perfect. Print a number that's 300 times greater than Z of 4. So print Z of 4, and then I want to multiply that with our star by 300. Give that a run. Awesome. And last, I want to print a number that's half of Z of 0. So half would mean divided by 2. So Z of 0 divided by with our little slash for division. Sorry, divided by 2, not 5. 7.5. So Z of 0 is our first number. So that makes sense. 15 divided by 2. 7.5. So feel free to look at these solutions a little more if you're copying them down. And this is going to be our very last, and that you won't have to write any code for this as we're running out of time. So let's just think about them in our head. So number 1 equals 1. This is a true or false question. So is 1 equal to 1? That's true. Number 1 is true. Let's look at number 2. I'll give you a couple seconds to think about that one. And the answer should be true because it's correct that 4 not equal to 10. That's correct. It's not equal to 10. Number 3, 2 greater than 5. I hope everyone knows that is false. I'll type these out next here. True. True. And this is false because 2 is not greater than 5, so that's false. So not 1 less than 2. This is where you really gotta, it'll really mess with your head. Like, okay, so 1 less than 2, that's true. So not true is false. So because this itself is true, not means the opposite. So not means whatever, the opposite of whatever is in front of it. So this is false. So 5 equal 5 and 5 not equal to 5. Remember, with an and operator, both sides must be true. Or if we have 3, then all of them, 10, all of them must be true. All 10 must be true if they're separated by ands. So 5 equals 5, is that true? Yes, 5 is equal to 5. But then 5 not equal to 5, that's 5 not equal to 5, what is that? No, 5 is 5. So because not both of those are true, only the 5 equals 5 is true and not the other one, then this is false. Because all of them must be true in order for an and result to be true. What about the or? We've got 5 greater than 6 and 10 less than 15. So only one of these has to be true with or. It's not the same. And you need all of them to be true, or you just need one of them to be true. So this is not true, but because this one, 10 less than 15, is true, that will be a true result. And if you guys are writing this down, that's great. If not, that's all right. We'll get the hang of it eventually. And here's a good example for whatever question was asked earlier about multiple cases. So we've got this, a bunch of ands. So that means all of them must be true. Every single one of these has to be true in order for this to ultimately be a true answer. So good. Okay, that's true. 1's equal to 1, 2's equal to 2, sure. 3's equal to 3, sure. But this one is not true because 4 equals 4, not 4 not equal to 4. So because not all of them are true, even though these 3 are true and this one's not, this is going to ultimately be a false answer. All right, a lot to take in, but when I'm with you all again next week, we'll get into some functions, some loops. We'll start doing some real conditional algorithms where like, oh, do this if this is true, do this if this is true. And they'll start to all kind of come together, and you'll see more of what you're capable of as a programmer come next week. I'll hopefully find a way to answer some questions. I know there's probably a ton that weren't answered, but we'll figure that out, and I'll send it back over to Kiera.
Awesome. Thank you so much, AJ. This was great. I learned a ton. So right now, if students are comfortable with the homework for this week, you're free to go, but I'm just want to make a few quick announcements, and then I'm going to turn it over to Simran, who's going to walk through getting you set up for the homework for this week if you're having trouble downloading the Jupyter Notebook or Google Colab. So quick announcements, there's going to be no lab this week. So you won't have your lab. There will be no attendance quiz this week. There will also be no homework review session on Friday or any sort of helping sessions. We'll actually be out of the office on Thursday and Friday this week. So please be aware that we won't be responding quickly to messages during that time. We will be having lecture next Sunday. Again, AJ will be going into more advanced detail on Python and some more advanced concepts like loops and conditionals and functions. And we will resume a normal schedule again next week of having a lab. You do have homework this week though. And with that said, I'm going to turn it over to Simran, who's going to go through how to access the homework and where you submit the homework, which will be in Canvas. So Simran, take it away.